start off by writing our title, if you didn't do it already, and making sure that you label this OMA number 39. And let's jump into our vocabulary. So notice that number 1 says review, right? Because we all know what sum is, and in case you forgot, that's why we're reviewing it. So sum is the answer, let's say, the answer you get when two things are added. Okay, so in other words, if we add up two things, the answer, the number you get, that's called the sum. Okay, let's move on to remote angle. Remote angle. Okay, any angle is remote if it's not next to. So the first thing I'm going to say is non-adjacent. I've heard people refer to it like that. But that doesn't help us if you can't remember what adjacent means. So remember back in the last set of notes last week, we talked about the word adjacent meaning next to. Okay? You know the word remote. If nothing else, you've heard the word remote recently. You've heard remote learning. And that's because you are where you are and I am way over here. And hopefully we're still learning. So I'm teaching remotely from far away and you're learning remotely from far away. And another good example is the thing we use when we turn the TV on. I bet most of you have never seen a TV that you actually have to turn a dial on the TV. Even though I'm 40, I remember having that, and because I couldn't afford a new TV, I had to use the old TV that my parents had, which had a turn dial on it. So, in other words, my point, you use a remote to turn your TV on. The idea of a remote is that it allows you to do something from far away. That's the physical remote, the technology remote, right? But you and I are remote because you're learning remotely and I'm teaching remotely. Okay, so how does that apply to this? How does that apply to geometry? Well, a remote angle is an angle that is not next to. So instead of just saying non-adjacent, let's write non-adjacent or not next to. And then we'll close up those parentheses. So a remote angle is, let's see if I have enough room. An angle that is not next to, getting tight here, another angle. That'll work. Okay? All right, let's move on to let's pick, how about a dark green? No, we used green already, silly. How about an orange? That's good. Okay, so, oops, that's weird. Let's try that again. Okay, so exterior angles, the exterior angle theorem, okay, says, and you actually have it on your notes. So if I jump back to page 1, it says that it states that the measurement of any exterior angle is equal to the sum of the remote interior angles. So we're going to try and write that up here. The measurement of any exterior angle is equal to, guess we can fit that over there, is equal to the sum of, let's go back and look at the wording just in case, the sum of the remote interior angles. Sum of the remote, I'm going to capitalize remote interior I'm actually going to throw a word in there. I'm sorry. I'm sure you're all like, ugh. Okay. The sum of the two remote interior angles. All right. Take a minute to write that down. Pause the video if you need to. And we're going to move on to the bottom. Well, it's the middle, really. The middle of the notes. Okay. So, my first little guy here is wondering... So, my first little guy here is wondering, who are the exterior angles? Okay. So, who are the exterior angles? Well, exterior means outside. Okay, so outside of what? Outside of, in this case, the figure. So ask yourself, who are the exterior angles? Go ahead and take a guess. Hopefully you said A, B, and C. So we're going to write A, B, C. Okay, they're exterior. Let's pick a different color for interior. Who are the interior angles? So now we're looking at this guy. This guy's saying, who are the interior angles? Okay, so interior means inside of, and in this case it means inside of the triangle, inside of the figure. Who are the interior angles? Take a guess, educated guess. Hopefully you said X, Y, and Z. Okay. Next we have a final thought here. So can you name, so now we're looking down here at the flag. Can you name two angles that are remote interiors with B? All right. Let's use blue for this. So thinking of B, okay, who are the remote interiors? Well, the interiors are X, Y, and Z. But Z is adjacent, okay? Adjacent. So we don't want Z. Okay. So that leaves X and Y, okay? X and Y are remote. So I'm going to try to squeeze. Let's see. Actually, I'm going to write a little more. Adjacent to angle B. In other words, you could say angle B. That's another way to say it. Angle B. Okay, so Z is adjacent to angle B. Z is not who we want. We want X and Y. X and Y are remote with B. So we're going to write maybe an arrow and write remote with angle B. Oh, that was a sneeze. All right. Weird. Excuse me. All right, let's move on. Here we go. Now, on the bottom, what does this mean for us? Well, again, I wrote it out. I would like you to write all of this out. You don't really need the boxes. You can spread out the examples however you want. But we have under my turn, we have, since the exterior angle theorem states that the measurement of any exterior angle is equal to the sum of the remote interior angles, then we can use this to find the measure of angle Z below. Okay, so we want to find Z, and what is Z equal to? Okay, well, the two remote interiors add up to equal the exterior. So what we're going to say is, we're going to say remote interior plus remote interior equals exterior. Okay? Now, it's not just any exterior. It's got to be the exterior that's remote with the interiors that we're pointing to. See how it skips over this angle? It's kind of jumping over that angle, okay? So let's substitute. What's the first remote interior from Z? 87 plus the second remote interior is 19, and that equals that exterior angle, which right now is Z, okay? So now we simplify. 80 and 10 makes 90. 90 plus 7 and 9 is 16. So 90 plus 16 is 106. So 106 degrees equals Z. 106 degrees equals Z. All right, so you could write these problems down and try them. You could pause the video, or you could just follow along. I'm going to keep going. Okay, so under your turn, we're going to do the same thing. Okay, practice number 1. So practice number 1 says find Y, right? I mean, we need to find Y. It doesn't say that. I could have written find Y. Y is adjacent with this angle. So it's remote with these two angles. So I like to circle the remote angles, add them up. So you could even put like a plus sign in there, and then equals, okay? Now, we're going to write it out like this though. 70 plus 23 equals Y, okay? Or you could say Y equals 70 plus 23. And then we get 93 degrees equals Y. Okay. Number 2, practice number 2. Now in this case, which angle are we looking for? Okay, we're looking for the X. But what's different about this one? What's different about this one is it looks like we only have one given angle. But that's not true. Okay? We've been told something about the sides. You see these tick marks? These tick marks are telling us that these sides are equal. So if they're equal, that means that their opposite angles are equal. And if their angles are equal, that means that this one over here is actually 57 degrees also. Okay, so we're going to write that in there. That's kind of hard to see. Maybe I can make the angle smaller like that. Oops. Oh, nuts. There. How's that? 57. Now, if that's the case, let's just make this a little better. Okay. Now, if that's the case, I'm going to use gray here to circle. I need X, okay? Let's see. I need X, and I need to add up my remote angles to X. So who are the interiors that are remote with X? 57 and 57. Okay, and I keep going, and I get 50 plus 50 is 100, and 7 plus 7 is 14, so 114 equals X. And don't forget the little degree symbol. Okay, pretty good. All right, that's it. Bye.